So, still more river problems, 5 through 7. I'm just going to really briefly talk about what I did here on number 5. Boat's going 3 meters per second westward. It's heading directly to the northeast. Speed in still water is 8 meters per second. So this is the resultant. That's the actual velocity of the boat. The heading and the speed in still water, the velocity of the water, those two are components. So component, and resultant. I think I was just writing out, drawing all my little vectors here. I have the boat velocity, that's the resultant. Boat heading and speed in still water is right here. And then the water velocity, that's what I'm looking for. So I've got the resultant, one component, I'm looking for the other component. And the first step is to identify the resultant and the two components. And then the next step is to take whatever you have, whichever vectors you have, and resolve them into x and y components. Then make a table like this and make sure that the two components add up to the resultant. And in this case, I have the resultant, I have this component. So I was looking for this missing one, which means I had to do -3 minus 5.66 to give me that. So I had these from the resolving, and then I found this. Once I've got that, those are the x and y components of my answer. I draw my diagram like this, draw the x component, y component, and find the angle using inverse tangent, and the magnitude using Pythagorean theorem. All right, number 6. Quadcopter. Sorry, I'm making sure that nobody interrupts while I'm working on this. Get in airplane mode. Quadcopter. It's a velocity of 20 meters per second in a direction 80 degrees north of west. So that's its actual velocity. That sounds to me like a resultant vector. The wind is blowing southward at a rate of 7 meters per second. So I've got the wind speed, that's a component. Quadcopter is airspeed and heading, that's the other component. So I'll take the two vectors that I already have and resolve them. So this is 6. So I'm going to call it copter velocity, and it's 20 meters per second, 80 degrees west of north. So this is north, 80 degrees west of north is about like that. And the velocity is 20 meters per second, so the magnitude of this is 20. So I want x and y components of this. Since I have this angle, I'm going to draw my y component like this, my x component like that. So y is positive, x is negative. And Vy, I'm not going to do all my work here, but it's the relationship between this leg and that leg is cosine. So I need to do cosine of 80 degrees, not in radian mode, 0.17, multiply that by 20, and that gives me 3.47. And then this, here's my angle, so this is opposite over hypotenuse, which is sine. There's the sine times 20, 0.684. Or 6.84. Now, wait a second. $80 sine? Ah, I did something wrong there. Sine is big, times 20. 19.69. Now that looks more reasonable. And I knew that 6.84 was unreasonable. This is such a big angle, and this is 20. This should be really big too. So 6.84 just didn't make any sense. I better check this again, see that I did that right. 80 degrees cosine times 20. All right, so that was fine. So those are my x and y components of the copter velocity. The other thing I'm given is the wind southward 7 meters per second. That's easy. 7 meters per second. So that is the y component. And the x component of the wind is just 0 because it's straight down in this picture. I know I'm using x and y, but I've got this map that's north, south, east, and west. You just got to be flexible. So now I'll make my table where I add up my components and get the resultant. So the resultant is the copter velocity. That's the resultant. Got to move this laptop away a little bit. It's crowding me. And the x and y components of that are x is negative 19.7. It's to the left. This is in meters per second. Guess I should put that. And then the y is 3.47. And the two components, the wind velocity is, the y is negative 7, and the x is 0. And then the one I'm looking for, this is the speed and heading. That's, I don't know. I'll have to figure that out. So this component plus this component should give me the resultant. So if I take the resultant, subtract the components, I'll have, or subtract the first component, I have the second. Negative 19.7 minus 0 is negative 19.7. And 3.47 minus negative 7 is going to be 10.47. So those are the x and y components of my speed and heading, assuming I did this right. I did the right process, but might have screwed something up. There's north. So x is negative 19.7. I'll go 19.7 this way. Y is 10.47. So 10.47 that way. And this is the actual, this is the resultant, this is the actual vector representing the direction that the quadcopter is trying to go, that's its heading, and how fast it's actually moving through the air. So to get that value, it's just the square root of this plus this. You can use that Pythagorean theorem. So 19.7 squared, sorry about the glare, plus 10.47 squared equals, and then take the square root, 22.3. So that's how fast it's moving through the air. That's the airspeed. And now for the heading, since I have this number and I have this number, I'm going to find this angle, and I can use inverse tangent for that because the tangent of that angle theta equals 10.47 over 19.7. So I can say the inverse tangent 10.47 over 19.7 equals the angle. So there's the tangent. Now I need to find out what angle that is associated with, and it's 27.98. So I'm just going to call it 28.0. And I need to give a direction. So this is the angle. Relative to west, it's going to be, I'm going to be swinging 28 degrees north of west. North of west. And if you did this a little bit differently, if you drew your triangle like this, then you would be getting this angle, which would be the complement of that, which would be 90 minus this, so 62 degrees west of north. Number 7. Golf cart on an aircraft carrier. Somebody's driving the golf cart on an aircraft carrier using a compass to head northward. The speedometer reads 6 miles per hour. So these two things together, this is the speed and heading of the golf cart. So that's not an absolute velocity relative to the Earth, so I know that's going to be a component vector. The aircraft carrier's heading is 28 degrees south of east, and its speed in still water. So again, let's see. Let's see how this is shaping up. So this is the other one. This is the heading and speed of the aircraft carrier. And then finally, we have the ocean current, which is northwestward at a speed of, or at a rate of 5 miles per hour. I see what was messing me up. We've got 4 vectors in this one. And then finally, what's the velocity of the golf cart? So the velocity relative to the Earth, that's going to be the resultant. And I've got 3 different component vectors that are going to contribute to that. First, we've got the way that the golf cart is trying to go and how fast. And then we've got the direction that the aircraft carrier is trying to go and how fast. And then we've got the direction that the ocean current beneath the aircraft carrier is going and how fast. So the water's moving one way, the aircraft carrier's sitting on the water trying to go another way, and the golf cart sitting on the aircraft carrier trying to go a third way. And those 3 things together are going to give us, they're going to determine which way the golf cart is actually going and how fast. And it might be it's not going anywhere. We'll find out. So first, I'm going to say golf, speed, and heading. I'm just finding the x and y components of all these. It's going northward at 6 miles per hour. So the x component of the velocity is 0. It's not going left or right. Y component of the velocity is 6 miles per hour. All right, so that one's taken care of. The aircraft carrier's speed and heading, 28 degrees south of east. This is a little more complicated. Aircraft carrier, speed, and heading. This is north. South of east. East would be this way. South of east would be like this. So we're talking about a 28-degree angle. It's going in this direction. And its speed in still water, it's 8 meters per second. So to resolve this, I can either draw my y like this and my x like that, or I can draw my x like this and y like that. That's how I'll do it. And if I draw it like this, it's different than if I had drawn it like that. To find x, I'm going to use cosine. So the angle is 28 degrees. Cosine of 28 degrees is that. Multiply that by 8, and that gives me 7.06. Now Vy, the relationship here between those two is sine. So 28 sine times 8, 3.76 miles per hour. So there we go. Got my second given. Third, the ocean current is northwestward at a rate of 5 miles per hour. So now the ocean current is that. And I know this is 45 degrees if this is northwestward. It's like this. So here's west, here's north. This is 45 degrees, the other angle is 45 degrees. So if you're familiar with 45-degree angles, you know that the y component and the x component are both going to be equal, and they're going to be this over the square root of 2. But let me label this 45 also. But I can use, and this, by the way, is 5 miles per hour. So to find Vy, I can use cosine. Cosine and sine are the same for a 45-degree angle. Times 5, 3.53, or 3.54 miles per hour, not meters per second. And Vx is going to be the same, but just for the heck of it, 45 sine times 5, 3.54. But of course this is to the left, so it's going to be negative. And then the last, I've got 4 things in here. The last one, that's the one I'm looking for, so I can't actually do anything. I'll make my table. It's going to be a little bigger this time. These are all the x and y components. I'll list my 3 component vectors and then my resultant vector here. So the 3 component vectors are the golf cart, speed and heading, and the aircraft carrier, speed and heading, and the current. And then the resultant is the golf cart velocity. And then I'll just write relative to the Earth to drive home. That's the proper resultant here. So golf cart speed and heading, x is 0, y is 6. Aircraft carrier speed and heading, x is 7.06. Y is negative, because it's down, 3.76. The current, x is negative 3.54. And y is positive 3.54. And this is kind of an easy one, because I've got all the components. I just have to add up their x values and their y values to get the resultant x and y value. So it's 7.06 plus, or sorry, minus 3.54 is 3.52. And 6 minus 3.76 minus, no, plus 3.54 equals 5.78. It looks right. I think I did that right, even though I stumbled. So this is all positive. Looks like it's going to the right and it's going up. This is north. The x component, or east-west component, is 3.52. Assuming I did that right. I should really probably check that. And the y component's 5.78. So this is going to be the square root of some of those squares. 5.78 squared plus 3.52 squared equals square root 6.76. That sounds reasonable, or 6.77 miles per hour. So that's the first part of my answer, 6.77 miles per hour. Now I need the angle. And to get that angle, I'm going to use the inverse tangent of this over this. (58.6 degrees). 0.7. So that angle, if I start at east and swing to the north of it, then I've got it. So my answer is going to be 6.77 miles per hour, 58.7 degrees north of east. And if I made some mistakes, they were minor ones.